What's up, world? My name is Dana Harris, in case you didn't know that by now. And I'm single-handedly trying to make math cool again. We have this thing called the new math, and parents want to know what's going on. Why does my child keep bringing home this crazy stuff, and every time I try to help them, they tell me, no, that's not how my teacher said do it. Here we go. So we're continuing on the subject of fourth grade fractions. And in this particular lesson, we are going to add and subtract mixed numbers. And I can go ahead and tell you, it's not going to be the way that you're used to doing it. But let's get into the math. Here we go. So I have 4 and 3/10 or 3/10. And I want to add to that 2 and 7/10. Okay. Now, based upon the previous understanding of how we rewrite this mixed number and this mixed number, we're going to stretch it all out and all that good stuff, and you're going to see this. So 4 and 3/10 can actually be written as, there's several ways we can write this. So we can say 10/10 plus 10/10 plus 10/10 plus 10/10 plus 3/10. And I'm going to kind of put a circle around that because that just represents 4 and 3/10. Okay? And then we have 2 and 7/10. So I have 10/10 plus 10/10 plus 7/10. Okay? And I'm going to put a circle around that. So this first little shape represents the 4 and 3/10. And then the second one represents the 2 and 7/10. And now you can say this is 1, 2, 3, 4 and 3/10, and then 1, 2, and 7/10. So in order to get our answer, the sum of these two, we can say there's 1, 1, 1, 1, 3/10, and then there's 1, 1, and 7/10. So we can take all the ones and put them together. So 1, 2, 3, 4, 5, 6. So we get 6, and then we have 3/10 plus 7/10, which actually is 10/10. So that's another one. So 6 plus 1, and that gives us 7 as our final answer. Now somebody's out there saying, why do I have to do all of that? That's like going around my elbow to get to your thumb. But once again, what we're trying to do is we're trying to get a student to really understand what the mathematics means versus just telling them, hey, this is what it is. So this 4 represents, we have a representation of 10/10, which is one hole, one hole, one hole, one hole. So they realize we have 4 holes and then 3/10. Okay. Same thing over here. They realize you have 2 holes and then 7/10. Now, some students are going to be able to say 4 plus 2 is 6, and then 3/10 plus 7/10 is 10/10, and so they'll be able to jump right here. That's fine, but everybody won't be able to do that. So we've got to show you the long drawn out way. That's example 1. Let's go to another example. Now, if I'm going to show you addition, we have to think about the opposite of addition, or the inverse operation of addition, which is subtraction. Okay, so I'm going to do this second example using subtraction. All right, so let's say we have 5 and 7/12, and we're going to subtract 2 and 11/12. Okay, I'm going to use a different representation of this. In this case, let's do we'll do a couple representations of this. So let's say that the 5 and 7/12 is, 5 is the same thing as 60/12. Okay, 60/12 plus 7/12, and we're gonna group that together. And then we're gonna take away, why am I drawing the shape before I draw the numbers? Okay, so then we're gonna say 24/12 plus 11/12. Okay, now it's time for the shape. Okay, so 60/12 is 5, because 60 divided by 12 is 5. 24 divided by 12 is 2. Okay, so that represents, this is just another way of representing the whole number part. And then we have the other part. So here I have 67 twelfths, if I can combine them, and then minus 35 twelfths, okay? And then from here, we can take the numerators and subtract them, okay? When we subtract those numerators, we'll get 67 minus 35 is 32, okay? 32 twelfths. Now, we still have an improper fraction, but we can rewrite that and make it look different, okay? So 32 twelfths is the same thing as 24 twelfths plus 8 twelfths. Okay, so 24 twelfths is 2, and then 8 twelfths. Okay, so this is our answer. Now, remember, this is also the same as 2 and 2/3. So either one of those is the answer. But remember, we want to be able to see both versions. So let's say you understand me all the way to here and you don't understand how I went from 8 twelfths to 2/3. Okay, well, let's put a visual to that. So if I have, let's see, this, and let's do one just like that. All right, so let's say 12. So let's go here. All right, and let's see. 1, 1, 1. So 3, 6, 9, 12. All right, and then let's say 1, 1. We have thirds, so that's 1/3, 1/3, 1/3. So, all right, or 1/3 as I like to say, and then we have 1/12. Okay, so I have 8 twelfths, and let's see, let's color them in. So 1, 2. Okay, now 2/3. Okay, so they take up the same amount of space. The only difference is these little pieces are 1/12 in size. These smaller pieces are 1/3 in size. So there's another example out of the way. Hopefully your child understands it better. Hopefully you as the parent understand it a little bit better. Hopefully I made it cool, I guess. I don't know. Young Guru's Math Tutoring. I have the solution to your math problems.